Dear students, detailed civil engineering courses like Manual Building Design, Stat Pro, ETABS, SAP, Revit, AutoCAD, Primavera, P6 are available at Civil Engineering Shravan online application app. So download the application from the Google Play Store now. Each course contains 50 plus high quality video contents and free PDFs and exercises, and online certification will be provided after completing the course. Course will be available at 67 to 70% discount now and valid up to 6 months. Download civil engineering application now from Google Play Store, or direct link is available at the description of this video. Try to utilize this offer. Hello everyone, welcome back to my YouTube channel Civil Engineering by Shravan. So in this video I will explain you complete analysis and design of tube-in tube structure by using ETABS software. So initially I will explain you how to model the tube-in tube structure by using ETABS software. Then after that I will explain you how to design that particular tube-in tube structure by using ETABS software, and I will explain you complete details about the modeling process, analysis process and designing process using ETABS software. Firstly, I will show you the model which is related to the reference of tube-in tube structure I am considering for my project. So here you can see this is the square building which is related to the tube-in tube structure, and this is the hexagonal shape building which is related to the tube-in tube structure, and this is the complete rectangular building tube-in tube structure. For this particular project I am considering rectangular building only for the modeling, analysis and design of tube-in tube structure by using ETABS software. So just I am selecting my ETABS software here. So click on the file option here, click on new model option. So from this modelization we have to select the third one which is related to use built-in settings. Display units we have to select as metric SI, and steel design as per Indian. Steel design code is IS 800, concrete design code is IS 456 2000. Click on OK option. Now after this we have to enter the number of grid lines which are presented in X direction, Y direction, and spacing between the columns as well as the number of the stories here. So here I am assuming number of grid lines will be consisting of 10 numbers in X direction, again 10 numbers in Y direction, and each spacing I am taking here as 4 meter as well as the 4 meter for this structure. Again in the same process, number of stories I am assuming G+15 building which is consisting of 16 floors, each will be consisting of 3 meter for the typical story as well as the bottom story. So here I am selecting grid only option for this particular building model of tube-in tube structure. Click on OK option here. Okay, so that the complete 2D model as well as the 3D model for the tube-in tube structure will be open here in the ETABS software, which is consisting of the plan view as well as the 3D view for the structure. Now we can see this is the 2D model lines and this is the 3D model lines. Now after this we have to define the material properties. For that go to define option, material properties here, click on add new material, select as per the Indian standard code which is related to the concrete. For this particular project I am assuming M30 grade concrete provision standard system. Click on OK option, again click on OK. Now after this we have to add the steel material which is related to the rebar grade also. So here I am selecting rebar grade which is related to HYSD of 500 grade here. Click on OK option, again click on OK option. Now after defining the material properties we have to define the dimensions for the beams as well as the columns. Go to define option for that, section properties here. Click on the frame section property here. So initially we need to delete all these particular frame sections. For that go to click on delete multiples option. Select this particular all the beams and columns which are presented here. Click on delete frames here. So again it will be presented to number of the section. Again we have to delete these properties also. Now again we have to add the new beam size, column size for the tube-in tube structure. So click on add new material here. So here I am selecting concrete rectangular property which is related to the beams and column section cross section. So here I am selecting and I am giving the name of the property is beam here, and select the material which is related to the M30 grade concrete provision as we are defined for this tube-in tube structure model. Now after this we have to enter the section dimensions as per our consideration. Just I am taking the beam size which is consisting of 460 and 460 for this particular beam. So click on the reinforcement option in order to change the property from the column to beam. So here we have to select the design type as the beam. Why? Because we are selecting this particular beam which is related to the 460 cross 460 dimensions as a beam cross section. So we have to select the longitudinal bar which is related to HYSD 500. Again this is also HYSD 500, and we have to consider the cover which is related to top cover as well as the bottom cover for this. So 40, this is also 40. Click on OK option. Again click on OK. Again select ISLB, click on delete property. Now we have to add the new property which is related to the column section. So here I am selecting the property name is column. Again we have to select the material as per M30 grade concrete provision standard system. Now we have to enter the depth of the column as well as the width of the column. Depth of the column just I am taking is 690 and width of the column I am taking here as 460 as per my requirements. So click on the reinforcement option. Now we will select the property as column HOSD 500, HOSD 500. Now we have to edit the clear cover as 40 and number of the longitudinal bar which is presented here are 5 and the longitudinal bar size is 20 and confinement bar is 10. Click on OK option. Again we have to click on OK option. Now after this we have to define the slab thickness for this beam, for this building. Go to define option for that. Click on section properties. Now we have to click on the section slab section. So let's delete the plank one initially. Now we have to modify the slab. So here I am selecting slab is approximately 180 mm thickness. I am assuming here. Slab will be consisting of the material of M30 grade. Again we have to select the slab thickness will be of 180 here. Click on OK option. After this we have to click on OK option. Now we have to define the shear wall thickness for the tube-in-tube structure. As per the considerations of the IS code provision standard system, the maximum size of the shear wall thickness will be assumed as 500 mm and the minimum size will be of 100 mm. You can consider any kind of the thickness between the 100 mm to 500 mm. So here I am considering 230 mm as the thickness of the shear wall. So go to define option, section properties which are related to the wall section. So modify this particular wall section, rewrite it as shear wall 230 and specify as per the material of M30 grade provision standard system. So here we have to assume the thickness which is related to 230 mm. Click on OK option here. Now after this we have to assign the beams, columns as well as the slab section and shear wall section for this particular structure. Before that we have to initially make sure that the building which is related to the assignment method of all stories option. Instead of one story here I am changing all stories option here. So select the assign quick draw beams option here and select the property which is related to beam. Drag to the respected model here like this. Again in the same process we have to drag to the columns also. Select the I section. Just I am selecting here. Select the property which is related to the beam to column here and we have to drag to the respected model here like this for this particular section. Now after this we have to assign the slab thickness. Go to select the slab section here. Just I am assuming which is related to the 180 mm slab. Just drag to the respected model here like this. Now we can see the complete model which is related to the beams, columns as well as the slabs are assigned for this building. Now after this we have to delete the slab section which is presented at the ground story level. Why? Because in general condition system practical situation there is no slab section which is exist for the building structural model. So for that go to select option here, select here, stories here, select as base section here, select here, close option. Again go to edit option here, click on delete option so that it will delete the all the slab section which are presented at the ground level. Now after this we have to delete all section which are not necessary for this building model in order to make the structure as tube-in-tube structure. So here I am considering for making of the building structural model into tube-in-tube structure, I need to delete this particular frame sections and slab section which are presented here for this building. So here I am selecting all these members which are presented at this particular location. Go to edit option here, click on delete option so that it will delete all the properties which are presented at that particular location. So now we can see it was deleted here like this. After this we have to assign that particular location with the shear wall section. So for that go to click on the quick draw walls option here. Okay, select here. So select the shear wall property here and just drag to the respected model here like this. Again in the same process we have to drag to the respected model here like this. Again in the same process just we have to drag to the respected model here like this. In the same process again we have to drag to the respected model here like this for this building. Now you can see it was make it as tube-in-tube structure now. Now we will click on the 3D model. Now we can see this is the structural model which we are made with the tube-in-tube structure considerations of the concept. Okay, now after this we have to define the load cases. So as per my assumption, just I am assuming my load cases for this particular tube-in-tube structure which is consisting of the gravitational load as well as the lateral load. Gravity loads I am assuming here as dead load, live load. In the same process lateral load I am assuming here as seismic load as well as the wind load condition system. So for that, initially we have to click on the define option. Select here as load patterns option. So here you can see it is consisting of the dead load as well as the live load. So in addition to the dead load, live load, I am assuming earthquake load in x direction condition related to the seismic load. I am taking the code book as per IS 1893 2016. Click on add property. In the same process, I am adding the earthquake load which is presented in y direction also. Again, I am selecting wind load which is in x direction, wind. Again, I am selecting as per IS code provision standard system 1893, sorry, not 1893. So after this, we have to select the wind load in x direction according to the considerations of the wind here. And we have to select the IS code provision system 875 2015. Again, I am selecting wind which is consisting of y direction condition system. Select earthquake load which is in x direction. We have to modify the properties which are presented in this particular section. So go to click on the modify lateral load. Select the direction which is related to the x direction with the per code value as per our zone consideration section. So you can consider zone 2 or zone 3, zone 4, zone 5 according to your assumption. So here I am selecting zone 5 condition with the medium soil with the importance factor is 1.3 value. Just I am assuming here for this tube in tube structure. Again I am selecting add button here. Again I am selecting wind, earthquake load which is in y direction. Go to select here as y direction condition system and this is 0.36 again. Again it will be consisting of 1.3 value here. Click on OK. Now after this we have to modify the wind load in x direction as well as y direction. Select wind load x direction, modify lateral load. Just I am assuming 44 is the load of the wind speed. So again I am selecting terrain category will be of 3 and importance factor is 1.3. I am selecting here as windward pressure coefficient is 0.86 and I am assuming direction which is in x direction of 0 and 180 degrees angle. Click on OK option. Again I am selecting wind y, modify here 44. So select here as terrain category which is of 3 and we have to consider it as 1.3 and this is 90, 270. We have to enter the values here 90, 270. Click on OK. Again per code value windward coefficient is 0.86. Click on OK option. Again click on OK option. Now we have to apply the load cases for this building structural model. Initially we need to assign a self weight. For that we have to select all the building structural model. Go to assign option here. Select the joint load option here. Select here as forces. So click on add to existing load condition system. We have to consider the values of the forces in XYZ as well as XXYYZZ as 111. Click on apply option. Click on OK. Now after this we have to apply the wall load condition system for the beam sections. So for that initially we have to calculate the wall loads for this tube in tube structure building. So in this tube in tube structure building I am considering the 3 combinations of the wall loads which is related to the external wall loads, internal wall loads as well as the parapet wall loads. So for the external wall load I am taking 0.23 is the thickness of the slab. I am multiplying this respected value with height of the each wall and I am multiplying this value with the unit weight of the brickwork 20. So that it will make as 13.8 kilonewton per meter as the external wall load. In the same process I am selecting 0.125 is the thickness of the internal wall and I am considering 3 meter height. I am taking 20 so that it will make it as 7.5. Again for the parapet wall I am selecting 0.125 is the thickness. Just I am multiplying this respected value with 1.2 meter. I am multiplying this value with 20 so that it will make it as 3. 3 plus 7.5 plus 13.8 so that it will make it as 24.3 kilonewton per meter is the wall load we need to apply for the beams. So for that initially we need to select here, select option, go to select the property. Here in this case just we have to select the wall loads which is acting on the beams. Just I am selecting the beams here, select here, go to assign option here, frame section, distributed load. We have to consider all add to existing loading condition system. Now I am selecting 24.3 kilonewton per meter is the value of the wall load which is exist for the external wall load and all wall loads with the inclusion of the external wall load, internal wall load as well as the parapet wall load. It is the combination. After this we have to apply the slab load. So initially we need to calculate the slab dead load for this particular section which is related to the floor load we have to consider. So if I am considering slab which is consisting of 0.1 thickness and multiply this respected value with the unit weight of the concrete so that motor so that it will make the values 2 kilonewton per meter square. So we have to apply that particular load to the slab. Further, go to select option, property, slab section, select slab 180 option here, select here, close option, go to assign option, select to shell section, uniform option, add to existing load, consider it as 2 kN per meter square, click on apply option. Now after this we have to apply the live load condition system. So for that again we have to select the slab section, go to select the live load option here, just I am assuming here as 3 kN per meter square. Okay, so previously I was selected slab section for applying the floor load condition system. In order to select the slab section, don't go to the select option and property option, just you can click on the PS option which is related to the get previous section. Okay, so select this, click on apply option, so that it will apply the slab load condition system which is related to the live load for the building. Now after this we have to apply the load combination for the building. Go to define option, select the load combination, add default design combination as per concrete frame design, concrete slab design, click on OK option. Now after this we have to apply the fixed supports at the base. Go to select option, stories option here, select the base option here, again go to assign option, joint, restraints, select the fixed support condition, click on apply option, so that it will apply the fixed support conditions at the base for the building. Now after this we have to analyze this particular structure. Go to analyze option, initially we need to check the models, just I am checking these 3 models here, click on OK, so that the complete model will be checked with no warning messages here like this. Click on analyze option again click on the run analysis option here, so it will ask you to save the model, just I am selecting desktop tube, just I am selecting here as tube in tube structure, save here, so that it will do the analysis process for this building model. Then after that we can easily proceed with the design of the building section by using ETABS software. Now you can see here it was done with complete analysis process. This is a deflection of the building and these are the displacement values for each and every node point which is presented for the tube in tube structure. In order to display the shear force diagram, go to display option, forces option, frame spandrella force, select shear 2 option and select your respective load cases or load combination according to your assumption. Click on apply option, so that it will display the complete shear force diagram for this tube in tube structure by using ETABS software. And click on moment option, 3 option, so that it will display the complete bending moment diagram for this particular structure here. Again if you select the torsion, click on apply, so that it will display the torsion for this particular building model by using ETABS software. Now after this we had to do the designing process after the analysis process. So initially we need to unlock the model. For that go to click on unlock here, click on OK option. Now we have to add the strip condition system for each and every floor for this tube in tube structure. Go to edit option, for that add edit grid strips, add strip condition, select the 16th floor which is related to x direction, A strip, click on apply, so that it will apply the strip in x direction. Again we will select the direction will be of y with the B layer, click on apply, so that it will apply the strip condition in y direction. Again I am selecting 15th story with the XA, click on apply. Again in the same process we will select as direction which is related to YB, click on apply, so that it will apply the strip condition system here like this. In the same process, in the same way we have to select apply all the strip condition systems which are presented for this building model up to the ground level. Now we can see we are done with analysis. Go to design option, concrete frame design, select view revised preferences, select as per IS 456-2000 code, click on OK. Again go to design option here, concrete frame design. So click on start designing check option, so that it will start designing of the members related to the beams and columns by using ETABS software. Now here you can see it was done with complete designing of the beam sections as well as the column section. Now we have to design the slab section. For that go to design option here, click on the slab designing section here, concrete slab design section. So select the view revised preferences, select as per IS 456-2000, click on OK. After that, again we have to click on the design option here, select the concrete slab design, select a start design check. Initially it will ask you to select the stories. Just I am selecting the stories here. Click on OK option so that it will design the slab sections as per IS 456-2000 code. Now we can see it was done with complete slab section design option. So now we have to save this model. Click on save option here. Now after this we have to close this ETABS software. Now we have to open the CSI detailing software. Just I am opening my CSI detailing software here. Click on the file option. Click on new detailing option. Select open EDB file. So here we have to select the file according to our consideration. Click on open option. So the complete model initially open in ETABS software, then after that it will be imported to CSI detailing version software. Now the data is imported here. Click on OK option. Now after this we have to select the detailing units initially. Select as metric SI as per the SI system, millimeter length, section thickness millimeter, rebar length millimeter, force will be in kilonewton, meter and square meter, cubic meter, this will be in ton option. Click on OK. Again select the preferences, select as per IS 456-2000, click on OK. Select concrete rebar rules option here. Initially we need to give the minimum value. Just I am assuming here as 120, maximum is 450. Again I am selecting beam. Yes, I am giving here as 120, this is also 120, this is also 120. Again I am selecting this as 450 value. I am assuming here this is 450 value, this is also 450. Select the column here. Again I am selecting this as 120. Again the maximum distance will be a 450 cover. Click on OK option. Again after this we have to click on OK option so that it will do the designing process, detailing process for the respected building structural model of tube in tube building by using ETABS software. It was done with complete designing of the building section tube in tube building by using ETABS. Select rebar plan option here. It will load the complete rebar plan for that particular respected model. So after this, if you want, you can load the reinforcement diagram which is related to the rebar cage view for this particular floor. Just I am selecting story number 16 so that it will show you the complete reinforcement details for this particular story. Now you can see here this is the reinforcement design results which is related to the 16th story for the tube in tube structure building. In the same process, if you want, you can see the beam detailing. Select here elevation section, select any one of the story. You can select any one of the beam so that it will show you the complete reinforcement design results. If you click on the rebar cage view option, so that it will load the complete rebar cage view for that particular building structural model which is located here. Okay, in the same process I am selecting column section. Select here column concrete frame, elevation section, select any one of the column. If you click on the reinforcement cage view option, it will show you the complete reinforcement cage view for that particular tube in tube structural model. So it is loading here. After loading process done, I will show you the complete reinforcement design results for that particular tube in tube structure column by using ETABS software. Now you can see here this is the tube in tube structure column design reinforcement design results according to our consideration. So this is the complete process of analysis and designing of tube in tube structure building model by using ETABS software. If you have any queries about this video, please try to text me your questions in the below comment box so that I will give you the answer for that question. Don't forget to like this video. Thank you for watching this video and see you in the next one.